In this problem we have a vibrating drum head that has a head length of 32 centimeters and the velocity of sound on this drum head is 343 meters per second. Now we're asked to find what the fundamental frequency of this drum head is. Now to find any nth order frequency or harmonic or fundamental frequency, we can use the formula Fn equals NV over 2L, where L is the length of our string or our drum head, V is the velocity in that string or drum head, N is now our order, the order of our frequency. So we have, for fundamental frequency, N is of order 1. So if we actually look at this on a string, let's say, that is a standing wave of order 1. There's one standing wave. Now, if we were to say our N was 2, it would look like this. So we have 2 standing waves, basically. So that's N equals 2. N equals 1, N equals 2. Now, fundamental frequency is always N equals 1. So, to do this, we say fundamental frequency F1 equals 1, velocity of 343 meters per second, divided by 2 times our length of 32 centimeters. Now, this is in meters, so we're going to have to put in 32 centimeters in meters, which is 0.32 meters, 100 centimeters in a meter. So our fundamental frequency, if we plug that in, turns out to be 535.9. We have two significant digits, so fundamental frequency turns out to be 540 hertz. Now, the other way you could look at this is that V equals F lambda. That's velocity equals frequency times wavelength. So if you don't remember this formula, or you have trouble with this one, you can just think of it in terms of this. You look at that and you can say that's exactly half a wavelength. Okay? We know our velocity is 343. We don't know our frequency, but we know our wavelength. Well, we can figure it out by saying this length, I know, I call it L, is 32 centimeters. But looking at that, that's exactly 1/2 of a wavelength. So my wavelength is going to be twice that. Wavelength is going to be 2 times L in this N equals 1 case. In this N equals 2 case, my wavelength is actually my length. So that would work out well. This wavelength would just be 32 centimeters. In this case here, though, wavelength is 2 times L, which is going to be 64 centimeters. And all we'd have to do is say frequency equals V over lambda, which would be 343 meters per second, divided by your wavelength of 0.64 meters. Which, now if we look at this, it's exactly the same. 343 divided by 2 times 0.32. And that's what that is, 2 times 0.32. So 2 totally separate ways of doing the same thing. And 540 hertz is your final answer.